Hello and welcome to Eaton's Power Systems Experience Center in Houston, Texas. In this video, we'll be discussing fundamentals of classifying hazardous locations and the associated risk within these areas. Hazardous locations, or HazLocs, refers to industrial applications that either process, use, or store flammable material, thereby potentially creating explosive atmospheres. To reduce the risk of fire or explosion, classified areas must be properly identified. This classification is for overall purpose of protecting operators and minimizing the risk of equipment loss. The public will perhaps commonly identify oil and gas refineries as hazardous locations. However, classified areas are diverse and include food manufacturing, water treatment plants, and pharmaceutical production, to name a few. In essence, hazardous locations have the potential for a fire or explosion due to the presence of three elements: a fuel, an oxidizer, and an ignition source. Combined, these elements form what is commonly referred to as the fire triangle. A fuel is any flammable substance that can ignite and continue to burn. The second component is an oxidizer. Often, ambient air, which is about 20% oxygen, will be enough of a reactant, and the last element needed to start a fire is an ignition source. Electricity is a prime source of ignition because of equipment, such as switches and motor starters, can produce arcs or sparks in a normal operation. Other hazards are devices that produce heat, such as luminaires and motors. Here, service temperatures may exceed the safe limits of many flammable atmospheres. Hazardous locations are classified based on three categories: classification or type of combustible fuel. Groups are nested within classifications, which are sorted based on combustion characteristics. And finally, divisions, which consider the presence of flammable fuels within the operating environment as normal or abnormal. The National Electrical Code 500 is one of the governing code models that defines the division system that we'll be discussing here. Let's begin with classification. Hazardous materials are categorized into three classes based on fuel type. Class 1 is designated for flammable gases or vapors, such as acetylene and hydrogen. The gases and vapors are then divided into groups A, B, C, and D based on combustion characteristics. This chart is an example of a gas or vapor for each group. Class 2 atmospheric hazard is reserved for combustible dust, which are grouped based on combustion characteristic. Group B is for metallics such as aluminum. Group F covers carbonaceous dust like coal or coke. Group G is organic elements, sugar and starch, for example. Class 3 covers locations where combustible fibers or flyings are present. Some examples include industries that work with textiles, paper, or cotton. And finally, divisions, which identify the presence of flammable fuels in the operating environment as normal or abnormal. Division 1 covers locations where the hazardous material can exist under normal operating conditions. Division 1 is also referred to as normally hazardous. In Division 2 atmospheres, flammable fuels will be present only during abnormal conditions. For example, equipment failure or improper installation can lead to an ignitable concentration being present that otherwise would not be. There are two additional topics we need to discuss: flammable limits and T ratings. Flammable limit refers to the concentration of fuel needed in the atmosphere in relation to the oxidizer to create a fire. This is also commonly referred to as the ignitable mixture. The upper level is known as the upper flammable limit, and any concentration above this limit is too rich to ignite. On the lower end, the minimum amount of vapor or gas that must be in the atmosphere is the lower flammable limit. Any fuel in the atmosphere below this limit will be too lean to burn or explode. While discussing the fire triangle, I mentioned that a possible hazard is the heat that electrical equipment produces. The risk is that the heat can raise the normal atmosphere temperature, contributing to the auto-ignition temperature. Each flammable element has an auto-ignition temperature, which is the lowest temperature at which it will spontaneously ignite, without the need for an arc or a spark. For this reason, the NEC includes the T rating table, which identifies the maximum temperature that each electrical equipment can reach within the classified location. For example, the auto ignition of temperature for acetylene is 305 degrees Celsius. Therefore, according to the T rating chart, equipment in the environment must be rated T2 through T6. Here in the Houston Power Systems Experience Center, we've replicated a HazLoc application to assist in training and education. For this video, it also allows us to show design differences between classified locations. For example, this cast panel board is rated for Class 1 Division 1 and is what we call an explosion-proof enclosure. This enclosure, on the other hand, is rated for a Class 1 Division 2 area, which allows us to use a stainless steel enclosure with encapsulated breakers. Here to answer some commonly asked questions is our Hazardous Location Specialist.
In the US, we use NEC Articles 500 to 516. Overall, internationally, we have the IEC 679 standards. Some equipment has NEC and IEC markings, so the equipment can be adopted better globally, depending on your region. In the Gulf of Mexico, we have some floating assets, like drill ships, that use IEC 679. The NEC 505 code we use in the US is a variant of the IEC 679. NEC 505 class and zone seems to be growing more popular than NEC class and division, certainly in the Gulf of Mexico. You can use Division 1 equipment in a Division 2 location, but the certification testing is more stringent. However, you can't use Div 2 equipment in a Div 1 location. Class 1 is for gas locations and Class 2 is for dust areas. However, some equipment has both Class 1 and Class 2 markings on. When designing a facility, there is a team that looks at risk, and the electrical member of the team plans their equipment not to be in the hazardous location. For example, if you install a floodlight in an unclassified location, it could shine into the division location. Using unlisted equipment can save an initial cost and maintenance, but sometimes using HazLoc listed equipment is unavoidable. There are different physical ways to mitigate an explosion happening with the equipment, and they are exclusion of the flammable substance, like pressurized, sometimes called purging equipment. Prevention of component sparks or hot surfaces, like a non-incendive system. Explosion quenching, like XP, explosion proof. And energy limitation, like what we call intrinsically safe.
Our hope is that this video has proven informative as an introduction to hazardous location classifications. To that end, the Eaton Engineering Service Group also offers various HazLoc training courses. If you want to learn more about hazardous location design or discuss your HazLoc application, please contact us or your local Eaton Crouse-Hinds sales representative to schedule a visit to one of our Eaton Power Systems Experience Centers today.